These are the solutions for the first practice quiz for quiz 2 in the third trimester of Algebra 2. So on problem 1, you're trying to determine, is this data that belongs to an exponential function of this type? And the answer is going to be it is. And you get this by just simply dividing backwards with successive dependent variable values or y values. And as you do this, I'm going to do this one time, and then the rest of the videos I'm just going to state that I did it. So 1.1, then 1210 divided by 1100, 1.1, then 1100 divided by 1000, 1.1. So because of that, and we have the coordinate 0, 1000, we have a coordinate at 0, a starting value there. This will be data that belongs to an exponential function of this form. And so you can just say because b equals 1.1 in y equals a times b to the x power, that will work. And then, of course, this is going to be 1000. So the original amount, as we did a little bit of in the last quiz, is this value that's sitting in front there. So you can graph it, you can look at the table, but that's the check that you have to do. And for logarithmic data, so the distinguishing feature here is that exponential data has outputs that are large and growing very large. And logarithmic data has inputs, for whatever reason, that are large or getting large very quickly. So the way that you can tell is, as you divide backwards, do you get the same value? The hard thing about logarithmic data is on a table, you're not going to see it this way because these are not equally spaced out. So you have to search for them actually on the table. And yes, this is going to be logarithmic data because b equals 3 in y equals log base b of x. So when you divide backwards, you get 3. And again, on the table, you won't see them in a row like this. You have to search for them because tables and calculators, or for online graphing calculators, they'll space these out equally. So you would see 1, 3, then 5, then 7, and you'd have to search those out. Okay, so it's just what column has the, when you divide backwards, you get the same value for each division. If it's in that X column, you have logarithmic data of this form. Now, not all logarithms are of this form. Not all exponentials are of that form. So we're just talking about very simple, basic exponential and logarithmic functions. Okay, and then graphing, as we did on the homework, what you should do is to go and get, the table right away. And you see 0, 2 there, that's the Y-intercept. So you can always get the Y-intercept from the table. And you can see that the horizontal asymptote is the x-axis, which is y equals 0. And the range is going to be y is greater than that. So in exponential functions, d and e are very closely related. This value will be the same. And then this will be all reals here. So the x-intercept, there will not be any, and here's the proof. So on x-intercepts, you let y be 0, and you try to solve for x. So 0 would equal 1/2 to the x power. And then when you go to do log base 1/2 on each side, it's just not going to work. Log base 1/2 of 0, you cannot have a 0 or a negative number in your set of parentheses when you do that. So it's just the fact that if you have a 0 here and you're going to do log base, you know, whatever it is, you can even on your calculator give it a whirl. Log base 0.5 of 0, you're going to get an error, non-real, or domain. So that's the way you can tell for sure if you do not have an x-intercept, it's just not solvable. And typically with these, you're going to get one or the other that does not exist. So we have 0, 2, and 1, 1. And all you need to do is just, you can get a few points here. I'm concerned that you get the asymptote correct so that you get the graph really close to it. And that you, right here, that's what I'm concerned about. And so for exponential functions, that asymptote is whatever's added on the end here. And there's not anything, so it's 0. So that's how you tell every time. Logarithms, the asymptote, so I'll pick right up with that, is you solve the x minus 2 equal to 0. So the vertical asymptote is x equals 2. And the range will always be all reals. Every logarithm, the range will be all reals. Okay, so let's get this in. So log base 10, because it doesn't say anything. So it's base 10 of x minus 2. So note that we actually, okay, we found the x-intercept on the table, 3. And it does not look like we have any y-intercept. So the thing that you have to understand a little bit, I'll zoom in here, is that this, that's probably too far, at x equals 2 is a vertical asymptote. And so to the right of that is the domain. So the domain and the vertical asymptote are related. These numbers are the same here, and it's greater than 2 because it's sitting to the right. But this is kind of a bad graph because it does drop down here and gets real close to the vertical asymptote. Now, as far as a y-intercept goes, if you let x be 0, so you always let the other variable be 0 and solve, it gives log of -2, which does not work. When you let y be 0, base 10 of x minus 2. So everything gets, or I should say, both sides go into the power position. So you have to remember how to solve logarithms, and you have to remember how to solve exponentials. So there's 3. Okay, and then everything up here. So the vertical asymptote or the horizontal asymptote, whatever is added on the end, down here you set what's in here equal to 0. And then to get both the x and y intercept, let the other variable be 0 each time. Or you can always try to get the y-intercept on the table. Sometimes for logarithms, you don't have one. So x equals 0. When it goes in, I didn't talk about this, 1/2 the 0 is 1, and then 2 times 1 is 2. All right, so this graph is going to look like this. It's going to get real close to 2 from the right, and you can get another point, so they don't grow very quickly. How about 7.7? Yep, it just does not grow. It is really because of the base 10. The higher the base, the flatter it is. Your logarithm. Okay, so that's the graph of that. Just realize again, the range and horizontal asymptote are related here, and the domain and the vertical asymptote are related down here. All right, so this problem, you are answering the opposite of this. What's everything but this? So from negative, so greater than 3, everything greater than 3 and everything less than 3, negative 3, sorry. So you have to see it like this. So in here's negative 3 to 3. That's all undefined in this. So anything greater than 3 will work, and anything less than negative 3. So you just need to think about the number line, really, in getting this answer. So if I say we have this, then that's the opposite. Okay, so whatever, you don't have, that's what you're answering. So greater than 3, less than negative 3 are the two. You can actually keep, or a way to think about it, like when the arrows are pointing in that direction, in that direction, that's the direction of your inequality also. That's kind of a weird way to look at it, but it does work. And then this inequality would be negative 3 to 3. So that you can sketch those graphs real quick, and that's another way to do it. All right, so that's the practice quiz 1 solutions.